Oh, these look good. Hi, it's Mia, and I am here with my new friend Gilligan at Woofable's Dog Bakery, looking through their selection of dog treats. I'm getting a few of these for my sister's dog, Rufus. That dog loves his treats. In fact, not too long ago, he ate too many treats. He went from a petite puppy to a paunchy pooch in no time. Stay right where you are, and I will explain how solving inequalities got Rufus's problem solved. Okay, Gilligan, let's have this one. Did you know that Americans own over 74 million dogs? That many dogs can go through a lot of treats, and Rufus has eaten his fair share. When my sister first adopted him, he only weighed 5 pounds, but the vet said that ideally he should weigh over 9. She suggested that my sister give Rufus a few extra treats to help him gain weight. If Rufus gains 1/2 pound per week, when will he be over 9 pounds? We can plot what is going on in this problem. This axis represents Rufus's weight in pounds, and this axis represents the number of weeks since Rufus went to the vet. We plot his starting weight, 5 pounds, and then plot at 1/2 pound increments for the weight gained each week. But when does his weight exceed 9 pounds? To answer that question, let's represent our situation with symbols. We will need to use an inequality since we are trying to find when Rufus weighs more than 9 pounds. We have his starting weight, 5 pounds, plus the 1/2 pound gained times W, which represents the number of weeks. We want to know when this amount is greater than 9 pounds. Since he already weighed 5 pounds, we can subtract it from both sides of our inequality. So we are looking for when 1/2 pound times the number of weeks is greater than 4 pounds. Next, we multiply each side by 2. W is greater than 8 weeks. It will take over 8 weeks for Rufus's weight to exceed 9 pounds. Here's how the answer looks plotted on our graph. The extra treats did the trick, and before long he was a full-grown dog. But the problem was he kept begging for more treats and growing and growing and growing. Before long, Rufus weighed 30 pounds. The vet said that he was a terrier with too many treats. His weight needed to be down under 14 pounds. If Rufus loses 3 pounds per month, how long will it take him to be under 14 pounds? We can also plot his weight loss plan. Here is his peak weight of 30 pounds and the 14-pound threshold. If Rufus loses 3 pounds per month, it looks like this. But when does his weight fall below 14 pounds? The inequality can be written like this. His current weight of 30 pounds minus the 3 pounds he will lose per month, or 3M, is less than 14 pounds. We subtract the 30 pounds from each side, leaving negative 3M is less than negative 16. It looks like we should now divide each side by negative 3. If we do this without reversing the inequality sign, we will find the number of months will be less than 5 1/3. But this does not make sense. The graph shows us that after 1 or 2 months, Rufus is still over 14 pounds. Let's take a look at what happens when you multiply or divide both sides of an inequality by a negative. It is important to keep in mind what is happening when we multiply both sides by a negative. Let's look at a quick example. We know 3 is less than 5. If we multiply both 3 and 5 by negative 1, we would get negative 3 and negative 5. Now when we write the relation between them, we would say negative 3 is greater than negative 5. The inequality symbol flipped. So when we multiply or divide by a negative, we have to reverse the inequality. Now back to our problem with Rufus. When we divided both sides of the inequality by negative 3, the relation changed from less than to greater than. So m is greater than 5 1/3. When you're solving inequalities, it is important to remember to change the inequality symbol when you multiply or divide both sides of the inequality by a negative number. Now we just gotta figure out what we wanna buy. You like this one? I guess so. Problem solved.